Until 2030, the UN has decided that we should invest a lot of resources in the science behind sustainable development of the ocean and ocean economy. Fisheries are surprisingly less valuable than a lot of industries and a lot of other natural resources. You can't bring a massive net, drag it along the bottom of the ocean, and catch as many fish as you want. There's evidence that these fisheries have been much better regulated over time. Once a species is extinct, that's it. If the species hadn't gone extinct, then we would still have the ability for the species to reproduce through time.
Hello and welcome back again to this episode of the Marginal Babble podcast. In today's episode, I sit down and talk to Dr Ethan Addicott out of the University of Exeter to discuss the fishing industry, specifically the permitting system in Alaska and how such systems affect the wider economy. Dr Addicott completed his doctorate from the Yale School of the Environment in 2022, and his research focuses on natural capital asset valuation, management and accounting. As ever, reference research material is included in the description down below, and without further ado, let's get into the episode. Enjoy.
Can you just give me like an outline of what the objective of this research was and what the goals and the methodologies you used?
Sure. So this research in particular is about solving a large problem that isn't exclusive to fisheries, which is dealing with managing common pool resources. Okay. And so in the sustainability class that I'm teaching now, one of the first things we talked about was I just asked folks in the room whether they thought managing renewables or non-renewables was a bigger challenge. And I think most people perceive non-renewables as the biggest challenge because we have a finite amount of them.
Right.
And as a result, we have to make sure that we use them in an appropriate way over time, in a way that comports with notions of sustainability.
Right. Sustainability being the opportune word there. Yeah.
Yep. But what's interesting about renewable resources is that because we have a potentially unlimited amount, there's more at stake. Because if we don't manage a renewable resource properly, we can lose it all. So think about the extinction of species. Once a species is extinct, that's it, right? If the species hadn't gone extinct, then we would still have the ability for the species to reproduce through time. So we've gone from a potentially inexhaustible resource to one that is exhausted based on how we manage it. Simply put, if you go from more than two fish and those two fish are enough to reproduce and you fish enough that you only have one left, you've just run out of fish, a potentially unlimited resource, right?
Right, and that's just where a lot of the conversation in regard to the fishing industry is sustainable fishing. I mean, there's obviously a lot of talk in the fishing industry as well, quite frankly, about the environmental degradation and stuff as well. I think something like 40% of like ocean waste is actually just caused by the fishing industry with cutting off their nets and things like that. But of course, as well with the actual resource itself for fish, as you quite rightly mentioned, you have to take some because it's a resource you want to use, but at the same time you don't want to take too many, so you're depleting your resources. So, what I'm presuming, and you can correct me if I'm wrong on this, and permitting in the different areas of the world, in this case in Alaska in your research, is really just to sort of manage that fishing quantity so that you're taking amounts, so it's a useful resource, but you're not actually overfishing and then hopefully depleting the population over time, I'm assuming.
Yep. So I'm going to maybe push to keep stepping back because I think the problem is more general than fisheries, and laying this kind of groundwork will help motivate why these permits were needed, right? So if you step back in time to where we don't have any kind of fisheries regulation, we had abundant fish resources in 1973 in the Alaska case. That's when I think the first permits were issued in Alaska. For a long time, we had used fishery resources. And in fact, a lot of what we know about ecology, so predator-prey dynamics, a lot of people might have heard about the Lotka-Volterra equations, which were the differential equations that described predator-prey dynamics, and how predator and prey species can be modeled so that we understand cycles of predator species being abundant, followed by prey species declining. The predator species declines then, and then the prey species comes back when there are fewer predators. Right. So these were described in response to a fisheries problem in the Adriatic Sea following World War I. And so someone noticed that the ratio of sharks to other fish that they caught in the Adriatic Sea was kind of puzzling, right? We would have more sharks in nets at some point prey species would decline, and they started observing the dynamics. And this was, I think, the son-in-law of Vito Volterra, for whom the Lotka-Volterra equations were named. And so fisheries management and fishery dynamics have inspired a lot of the models that we have to understand how the natural environment works, and more importantly, how the human environment and the economic system works in tandem with the natural environment. So there was a time when we didn't have a lot of fisheries regulation and fish stocks were open access. And open access causes two problems. The first problem is that because there's a high cost of excluding boats from entering a fishery, everyone can bring their boat and try to access fish that are shared as part of a common pool resource. That leads to overfishing. So long as there are fish in the ocean, why would I leave fish for a future year for me to fish when I know that someone else can come in and take those fish before I can return the next year?
Almost seems like a game theory, something like a prisoner's dilemma.
It's exactly the same situation as a prisoner's dilemma. So because other people have access to this resource unfettered, I'm going to over-extract relative to if I was the only person who had exclusive property rights over the fish. That also led to this interesting phenomenon, not just overfishing, but something called overcapitalization. And so this is a more economic term. Overcapitalization means that I see that this fishery is really profitable for my neighbor, so I order a bunch of boats because they're making a lot of money. Now, all of a sudden, the fishery is depleting, but there's this lag as all these boats are delivered that I've ordered.
Right.
So you have way too many boats in the fishery than is efficient, and you have way too much extraction in the fishery than is efficient as well. And that leads to fisheries collapse, which is generally defined as having less than 10% of the maximum harvest in the past. By 2003, something like a third of the world's fisheries had collapsed. And so this was a big problem. And this led to a movement broadly known as fisheries rationalization. And fisheries rationalization was all about controlling access to fisheries and trying to internalize this market failure, this externality of too many people being allowed to fish in a particular access area.
Kind of surprising, actually. 2003 really wasn't that long ago.
Wasn't that long ago.
So you're saying that before then there was just open access operation in terms of fishing for most of the world, at least?
There were quota systems and permits that were issued before that.
Right.
I think it was 1974 that the Commercial Fisheries Entry Commission in Alaska started issuing these access permits.
Access permits, yeah.
And there's a nice paper by Chris Costello and others in 2008 in Science that talks about these quota programs. They're called tradable quotas or ITQs. These individual tradable quotas were used to manage access to the fishery and allow individuals only a share of access to the fish. And what that would result in is the fisheries managers could say, okay, we have fewer fish this year. We're going to set something called a total allowable catch, which is how many we're allowed to collectively extract. And each permit or each ITQ entitled an individual to a share of those resources. And these permits are one of the tools that we have to address market failures. We use permits for carbon emissions. We use permits potentially for things like nutrients and biodiversity, especially in the UK. And so these tradable permits or sometimes credits or things, these instruments can be used to help address over extraction or other market failures.
Are those similar to carbon emission tradable options, where if you as a company want to pollute more than the regulated amount, then you can buy X amount of pollution permits basically from this. So it allows you to do that, but it means that there's almost like a capped amount of pollution that can go on in the market, basically.
So just like cap and trade, as you mentioned, where you cap the amount of pollution and you give people permits and they can trade them. For fisheries, we have a cap called the total allowable catch for some fisheries, and individual tradable quotas, ITQs, that are the analog to the permits. So these permits were used to try to manage these fisheries. A third of the fisheries had collapsed by 2003, nearly a third of global fisheries, and this Costello paper provided some of the initial evidence that these ITQ programs were actually working. And that's why this is great, is it showed that fisheries are able to recover and that this fisheries management strategy was working. So that was really nice. The Alaska paper in particular was us trying to think about another type of market failure. And this is a way that these policies could, even with tradable permits, could fail. So how does that failure work? Essentially, you overfish salmon, and I want to regulate your salmon fishing. So I say, this year we have too few salmon, and I'm sorry, Max, you do have a permit to fish, but your 10% share of the allowable catch is now 10% of 10 fish instead of 100,000 fish. And two things could happen. You could try to sell your fish for a high price to recoup the revenue that you would otherwise have gotten from catching more fish.
Right.
But you might not set the price in the market.
Mm-hmm.
So that might not be enough revenue for you to make ends meet. You might have to exit the fishery.
And customers might not be willing to pay higher prices. Yeah.
Customers might not be willing to pay higher prices for Max's boutique salmon. So what do? You might go and fish in another fishery that you also have a permit for. And so we were interested in this thing called a leakage or a spillover, which is the idea that a policy is ineffective because when we regulate one location or one component of a system, people start doing things in other parts of the system that we don't want.
Right.
And the example could be you go out and catch another species of fish that isn't regulated or that you have a permit for more intensely than you would have otherwise had we not put this policy into place.
I see. So on top of this as well, it sounds as though the individual fishermen or fisheries, people that are fishers, I guess, fishermen, fisherwomen, whatever. It sounds as though they can actually get different permits for different areas. And it sounds there's different permits for different areas, but also for different types of fish by the sounds of it.
Yeah. So there's a lot of setup to try to understand how this kind of fisheries world plays out. So in Alaska, when we say a fishery, what we mean is a species of fish that you are fishing in a particular place with a particular set of technology. And we call that technology gear. So a fishery, so fishing salmon in the southeast of Alaska with longline is a different permit than fishing salmon in the southeast of Alaska with a different type of net, so a gill net or a purse seine net or something. And not all species of fish use the same sets of technologies. So there's different types of technologies or gear that you can use to fish different fish, and then you can do that in different places.
Mm-hmm.
And so what we looked at were these weren't individual tradable quotas, but these were permits that allowed people just to fish or enter into a fishery. Some of these fisheries then had tradable quotas that were installed on them. So one permit says, I'm going to limit the number of people that can come play at the playground.
Right.
And the other permit had to do with how long you could play at the playground or the quantity of fish that you could extract.
Okay.
So we looked at the permits that allowed people to enter into the fishery. And these are these access permits. Now, these permits were given out in the 70s. They're kind of use it or lose it. So if you don't use it in a particular year, you lose the permit and you'd have to apply to get another permit in the future, which may or may not happen. So there's a qualification process. So you have this permit. It allows you to fish in the fishery. You've got to use it every year, or you can transfer it to someone else or sell it.
Mm-hmm.
You can't lease it. And so there's a number of rules around these.
Okay. You can sell it, though.
You can sell it to someone. And you can transfer it to your son or your daughter.
So at least just being, then you're selling it for a particular period and then you get the rights back to it. Okay. But so if you sell it, you have to sell it permanently.
You sell it. Yep. Right. So there's not this like leaseholdership over permits, these entry permits in fisheries in Alaska. So all these permits are issued, these entry permits, and altogether in the data that we collect in about 10 years in 2000. So I think 2006 to 2015. So from 2006 to 2015, we look at 21,000 permit holders across 113 fisheries in Alaska. And again, these fisheries are defined by species, gear, location.
Right.
And we only look at the fisheries that have more than 5 permits issued in them. Mm-hmm. So we want to exclude the kind of super boutique fisheries.
Yeah, the kind of smaller fisheries. So maybe I don't know, unique fish or something where there's only like 5 companies that are actually going out and fishing that with that gear in that location.
So it could be free diving to catch abalone off the coast.
Oh, right. Because I suppose free diving comes into that as well. Because obviously when you think about this, you think about all the big ships and sort of fishing sort of on a much larger scale. But I suppose some of these with the gear specification, I suppose it's actually, you can actually have fishing on a rather much smaller scale as well, actually.
Yep. So there's all different types of fishing technology, many different places that you can find the same species of fish. In general, what are the fish species that we're talking about in Alaska? we're talking about halibut, which is the largest of the fisheries that we looked at. We're talking about salmon, crab fisheries. These are kind of the types of fisheries or the fish species that we're talking about. And then for each of those species, there might be an associated location. And so what we were interested in is identifying, kind of back to this idea of spillovers.
Mm-hmm.
If we regulate salmon with a particular set of gear in a particular location, and we limit relative to a previous year your ability to operate in that fishery,
Mm-hmm.
do you go out and overfish in a differently regulated fishery that you also hold a permit to?
Oh, I see. So it's this idea of if you have like in one specific fishery, if you tighten the regulations and sort of the rules and regulations around fishing within that fishery, does it have some negative externalities in other fisheries, basically?
Yep.
You know, is it just being transferred to another area?
Exactly. And so we can define spillovers as these impacts that happen in other places from a change in one location.
Right.
Spillovers can be positive or negative.
Right. Yeah, true.
Right.
Yeah, fair.
Leakage is a type of spillover, and leakage is when the effect of a policy is diminished because of loopholes.
Right.
Because of ways that people can avoid the regulation by doing some other behavior. And so what we're looking at in this paper is we were trying to identify the opportunities for spillovers and leakage, for loopholes, where when we try to regulate one fishery, someone could go harm the ecosystem by doing something else in a particular area.
I see. So you're really just trying to identify if there is any sort of loopholes within the current policies, and whether, like you say, there is, sorry, it's not a type of spillover, it's
Leakage.
Leakage, sorry. I knew it had become with now.
Yeah.
Whether there's an opportunity for leakage and whether it could be exploited, which I presume the results of this research in terms of the takeaways, things like that, would be potentially a conclusion about how you could mediate this and to avoid that from happening.
Totally. So what did we find? If you were to close your eyes and pick two fisheries out of the bin of fisheries that we were looking at, so the 113, 1 in 3 of those would share a common permittee. So there would be a fisher who
Also had that one.
at least one fisher who would be able to fish in both of those fisheries. So there was a huge amount of connectedness. If we look at, so we use these tools from network analysis, and we're really used to, I think, these tools now from thinking about the COVID pandemic, from thinking about social media, all of these graphs with a bunch of dots called nodes that are connected by edges that demonstrate the connectivity across individuals. That's exactly what we're looking at here. And so we'd represent each fishery as a node, and the edges, the connections between the nodes, those were permittees, fishers, that were in common across the two fisheries. So 1 in 3 were your chances that two random fisheries had a common fisher.
Right.
Now, if there was a connection, if there was a common fisher, then the average number of fishers in common or permittees in common, I believe, was 5 or 6. So that's good. Each connection on average had 6 common permittees. And the average fishery had 35 permit holders in common with other fisheries.
Okay.
So the average connection was 6 fishers. The average node, the average fishery shared 35 connections with other fisheries. So what this did is, all in all, we were able to produce this big graph, this big picture with a bunch of different lines and dots that helped us understand how, if we regulate one node, one fishery, what are all of the different avenues by which people could shift their fishing patterns to other fisheries? What are the opportunities for spillover?
Right. And so did you identify that there was a lot of opportunity for spillover?
Yeah, I mean, there were large opportunities for spillover, evidenced by how common and these connections between fisheries are.
Yeah.
Almost the entirety of these 113 fisheries were connected. So it's one big graph with kind of a couple of exceptions of individual boutique fisheries that don't share fisheries in common. So that means that you could kind of play the, 7 degrees to Kevin Bacon. You could start with a fisher that fishes in one fishery, and very quickly, through just a couple of fishers, end up in a completely different fishery through these kind of handshake connections of shared fishers.
Sounds a bit like a tongue twister. How many fisheries in a fishery can...
How many fishers in a fishery? Yeah, exactly.
But with that level of connectedness, though, is there... Well, I guess that the question really is, obviously there's an opportunity then for there to be leakage in this Alaskan industry, this fishing industry. But just because there's opportunity for it doesn't mean that it's necessarily occurring. Do we know what the results are or the data is on how effective or not effective, but persistent it is?
Yeah, so I think the question has to do with something that we weren't able to answer in this paper.
Mm-hmm.
So, this paper was as a part of an internship that I did when I was in grad school. It was at Resources for the Future, which is an independent nonprofit research group in Washington, D.C. that broadly focuses on energy and environmental policy.
Mm-hmm.
And so I was working with a research fellow there at the time, Dr. Kaylin Krowitz. She is at Arizona State University now, and she led the project. And this was a one summer internship where I did a lot of the data crunching and the analysis for the paper. We also worked with other researchers as well in the published version of the paper. Now, we only had access to the permitting database. So we only knew who was allowed to fish, but we didn't have access to landings data, which is how many fish were harvested.
Right.
And as a result, we don't have information about how a change in a policy could end up changing the quantity of fish that were, or the magnitude of these spillovers in different places, the quantity of fish that were extracted as a result in other areas.
Right.
All that we could say was after, for instance, a quota was put into place on top of the people who were permitted to fish in the fishery, did that cause fishers to make new connections, drop out of fisheries, or change where they were allowed to fish?
Right. Okay.
That makes sense?
I think so, yes. So has there been any research since then that's been able to ratify that, or has there been any data at all? Or
I'm not 100% sure about that in the context of Alaska.
Right.
I know that that's a very interesting question, and broadly there's a large literature on something called ecosystem-based management.
Okay.
Which is the idea that instead of controlling one particular commercially valuable species by limiting the number of people that can access it, we instead think about how we manage an entire ecosystem. And what I think this paper did that was really nice is it thought not just about the connections. When you think about an ecosystem, what you'd think about immediately is, well, if we want to control a valuable prey species, we can either limit the amount of prey that people can catch, or we can also go in and regulate something about the way the predators interact with people. And if we are able to do a combination of those, we might have more opportunities to achieve a sustainable target or something.
Yeah.
This concept of ecosystem-based management says all of these fisheries might be related ecologically,
mm-hmm.
but if we look at it through a socio-ecological perspective, what are the connections among the people that are operating on the fishery that allow us to manage it in a different way?
Mm-hmm. So
maybe the regulation isn't about a particular fishery, so gear, species, location, but instead, if the commonality among a lot of people who share permits in a bunch of different fisheries for salmon is that they share a particular technology, that might justify technology-based regulation. You can only use this particular type of net, as opposed to limiting the number of fish that you can catch in that particular niche.
Yeah. Okay, so it's pretty almost as if maybe limiting the technology that can be used rather than the amount that can be used. Well, limiting the technology that you used to be able to catch the fish will limit the amount of numbers of fish that you can catch, of course, because obviously better technology will catch more fish and stuff. But that still allows for some kind of like competitiveness in the market, but like individuals still have being able to go out, being able to essentially work their own hours potentially. So if like they want to work less, they can work less and get less, and they can work more and they can get more. It's kind of like a better way of mediating the issue potentially.
And this is that's a really good point actually to circle back to, which is there's many different ways that fisheries have been regulated in the past and are regulated today. Mm-hmm. One of them is a technology regulation, and this is a type of command and control. So it's saying for factories, you can pollute as much as you want, but you have to have a scrubber on top of all of your smokestacks that reduces the amount of pollution that comes out. For fisheries, this could say, we're going to reduce the number of fish that you can harvest by limiting you to something that can only catch a small amount of fish, some kind of technology. You can't bring a massive net, drag it along the bottom of the ocean, and catch as many fish as you want. Mm-hmm. You have to catch them with hooks or something.
Right.
These can lead to that overcapitalization problem, because what happens, you go out and instead of having one maybe more efficient net, you go out and you buy loads of hooks. and you spend
Right,
more
okay,
money
yeah.
and you spend more resources to harvest the same amount of fish. So that can be a problem. And there's a huge debate in economics, or a huge literature rather, on whether a price instrument, something that changes the either with a tax or a subsidy, the price of a resource. That's not the best way of explaining it, but a tax would raise your private costs of harvesting so that it's less efficient for you to harvest more fish. A subsidy would potentially make you harvest more fish rather than fewer fish.
Mhm.
So these are price instruments. And the nice thing about a price instrument is if you know the magnitude of the externality in dollars,
Yep.
the price instrument will let you hit that without having people use an inefficient technology. A quantity instrument says, I'm only going to let you harvest a certain number of fish, and the price is going to be determined by the market.
Mhm.
And an additional way of restricting quantity is to try to impose a technology restriction.
Right. So kind of what we were saying earlier about, it's kind of like, it's really, well, it affects both price and quantity, right? Because you're not getting as many fish, but also, the availability as well, which is kind of interesting. But yeah, that's something I hadn't thought about as well, because obviously allowing better technology to be used, you do get a level of economies of scale, probably maybe less equipment because they're spread along, maybe less fishers, I would imagine as well. Although there might be some significant damage done with specific pieces of equipment as well. But, maybe that's something to sort of potentially outline as well. Maybe a technology permit system would work well if a particular technology, even though it's efficient, does a lot of environmental damage or like degradation,
Mm-hmm.
as opposed to it simply just being a very, very efficient methodology of catching fish.
Yeah, I hope I'm not wading into too far away from fisheries with this technology. This is a broader issue in environmental economics, but one good example about kind of why technology might be a bad way to regulate a market or an externality or a resource is that imagine someone says, I want everyone to use the cleanest technology. So you can only participate in the fishery if you use the best, cleanest technology to fish.
Right.
And this is a technology that avoids bycatch. And we can think about an analog as like everyone has to have the newest iPhone today. So that would be an iPhone, 15 are we on or something?
I think so, yeah.
Okay.
It's going to be more power efficient, it'll charge faster, less little bits.
Spyware, whatever.
Sure. Yeah.
So everyone has an iPhone 15. So the legislation we pass, we get the government to approve everyone who uses a cell phone must use an iPhone 15 for safety and security reasons and efficiency and whatever. Now, if the government doesn't get around to changing that and a more efficient technology comes along, we have now legislated a less efficient technology by default.
Right.
And so the market isn't allowed to allocate resources efficiently because we've constrained everyone to using what we thought was the state of the art, but 10 years later is now basically a brick.
That's literally, as soon as you sort of brought up that sort of limiting of that, the first thing I thought was, how do you define the most efficient technology? And on top of that is maybe I didn't quite think about as much about, as you outlined, the bureaucracy around this legislation. It takes time.
Mm-hmm.
Now, in some countries, that's more. Sometimes, in some countries, that less. In America, stuff will probably take less time than it does in the UK, for example. Just
really
notoriously,
depends.
or Japan, very bureaucratic. But yeah, so exactly. So as technology moves on, and let's be honest, technology has moved on. In the last 10 years, probably more so than it has in the last 50, 60, 70, right? So it's not, so it's a small problem in that regard.
But your question was really, really, so what you said there was really, really interesting, which is how do we know what the best technology is, or how do we know what the most efficient technology in any time is? And another way that we could pose that is, how do we identify the most efficient fishers? So let's say that we wanted the most efficient fishers, the people, the individuals who can fish a particular amount with low costs, with little environmental impact, low bycatch. How can we identify those people that are best suited to do this? And we could go and ask them, and that's tough and involves a lot of time and research. And we have the same types of questions in emissions regulation when we try to figure out who's the most efficient power plant, which power plant can produce power with the lowest environmental impact. It's very, very hard to determine this, and you'd have to go to each individual power plant and ask, how efficient are you? Yeah. Tradable permits, though, have this very excellent quality that because you can trade, they're going to satisfy this kind of equimarginal principle,
Right.
where the least efficient people are going to sell their permits to the most efficient people,
Right.
because they'll win out when they sell their permit. That's just a transfer. So
because
there's no
because they're just more efficient at the role in whether that be energy costs, all these kind of things. They're going to buy up those things because they're just making more profit on each permit than somebody else, right?
Exactly. And that is the beautiful thing about tradable permits, is that you don't have to go and figure out who the most efficient people is. Adam Smith's invisible hand will tell you who these individuals are.
That's actually really interesting as well, because a lot of what gets talked about with particular capitalism, like I say, Adam Smith's free hand, right, is you need to let markets do their thing, whether it be technology. You need to let the markets be guided by the free hands, the most efficient or the most value producing producers, because they're the ones that are going to add most value to the society, allows for better competition and all these kind of things. And then what's sort of countered with that is actually sometimes you get monopolies, people buy up the resources, and then there's no competition and things like that. But also there's negative externalities that come with certain aspects of capitalism. So just because someone's really creating a lot of value in one aspect, they could be creating that could be a lot of pollution, could be water degradation, could be anything, right? Could be a whole host of things. Could be a phone that's really, really efficient, but it sells your data and things like that. And so there's other concerns around it, right? So regulation or other forms of governing or economy would say that no, you need some regulation to mitigate these things. But then the capitalists would basically say, okay, but you're mitigating a lot of our ability for the free hand to work, essentially. And actually, I did an episode not too long ago in regards to the British rail industry. And they kind of had a lot of the similar problems there. And the rail industry in the UK is very specific, right? It's a utility sector. There's rail lines. It's not like a food shop. You can't just set up food shops you can set up food shops wherever, sorry. You can't just set up rail lines everywhere. It's a big industrial project. A lot of capital there gets invested in things like that. And we were talking about a lot of the issues that were going on, quite frankly, because when the franchising models were going on, what would basically happen is the government would franchise out these, but the idea was that it would franchise out these rail sectors or segments or cross times to people that would tender for them. And then that would allow, and they could set what the quotas were, so they could make sure certain regions didn't get missed and things like that. But it still allow market capitalism to work because people could tender and most efficient would come in. The problem is what would actually happen, they put so much regulation on it that actually no one could really make any money on it or anything like that. And so what ended up actually happening is people would just under tender, they would get accepted, and then they would basically go bust, and then the government would have to come in, sort them, or end up having to come to some sort of arrangement. It was in a hyper inefficient situation, and now we've actually moved to a concessionary model where actually the government, essentially post-COVID, is really that they just pay the rail operators basically cost plus for like a certain amount on a markup, essentially. So that's a situation where people would say, obviously, that hasn't worked very well. But the really nice thing about what you're saying with permits is it really is guiding the individual fisheries or fishers. Sorry, I'm getting confused between fisheries, fishies. The individual fishers do actually have still a lot of autonomy in how they actually operate. They're not selling, they're saying it's the catching equipment, but everything around that, the hours, times, like all this kind of stuff they can choose, and they can choose which permits they want as well.
Yep.
And what also allows, by trading permits, it also allows for the most efficient fishers to actually be able to sort of take up a good portion of the market and then still have their competition. So it actually kind of seems like quite a nice system. I guess the professional skeptic in me would then come and say, okay, well, what's the downside to this situation?
Well, the downside are things, exactly the problems that we were trying to address in that paper, the opportunities for spillovers and leakage. What are the loopholes?
Right.
And, I mentioned a technology regulation, and we've talked about why technology regulations might not be good. So what we're trying to do is say, okay, we've shut the door. What windows just opened that people are going to jump out of? And which ones should we try to maybe put locks on ahead of time to avoid this spillover, to make sure that we don't tank the ecosystem? So if we've identified a particular fishery that's sensitive, we've regulated that, and we know the avenues for leakage, can we also, in tandem, enact policies to regulate the cap on those other fisheries to avoid these spillovers and these negative externalities?
Okay, I see. I think we may have gone over it slightly, but how did you go about collecting the actual data for this study? I mean, you mentioned the numbers in terms of how many fisheries and individual fisheries you mentioned, but in terms of actually collecting the data and actually going out and getting it, what was your methodology in that regard?
So this was all public data from the Alaska Commercial Fisheries Entry Commission. So it's a big table of all of the permits that have been issued and the transactions over time. So we were tracking individual permits and permittees, and it told you what year and species, gear, location.
Okay, so it's just really more of a case of importing that data and being able to do the appropriate data analysis over it to come up with an effective conclusion.
Putting it in some network analysis tools and trying to map the overlap between the fishers.
Okay. What tools did you use out of curiosity? Because I literally, the last episode that I did was on econometrics and a variety of data analysis tools and how businesses can use it and things like that. So I'm just curious to kind of the tools you use. Were you using programming languages? Were you using, were there actually formatting and visualization softwares you were using? I don't know.
So we used Python for most of the project to try to get this database. Mm-hmm. Essentially, a network graph is a big matrix. It's an adjacency matrix. And so the entries of the matrix are the number of fishers in common between two different fisheries. And on the diagonal, you have all the people who are permitted in each fishery, right? There's the connections between yourself and yourself for you, or the number of people that are at the particular fishery. So we use Python for that. And then there was a network visualization tool that's open source called Gephi that we use, GEPHI.
Okay, sounds great. What policy changes would you like to potentially see, or do you think would be effective by the Alaskan government to sort of help improve the industry, if that's even at all possible, or is it just better to leave it alone currently?
So the fisheries regulation in the United States and this kind of rationalization program of regulating entry into fisheries and using quotas in some areas, this was all stemming from something called the Magnuson-Stevens Act, which was a legislation about how we should use ocean and marine resources. And since the Magnuson-Stevens Act and since the use of these things like quotas and permits, fisheries have been really much better. There's evidence that these fisheries have been much better regulated over time. That's not the case for every single fishery, for sure. But in general, these things have really improved the way that we manage.
Is that globally, or is that just...
That's for the United States.
For the United States specifically.
If we want to think about global fisheries, we have to think about how... So there's fisheries that a country has sovereign rights to, and these are fish resources or marine resources within their EEZ, their exclusive economic zone. Mm-hmm. And that's defined by... there was a UN convention on the use of marine resources that defined this 200 nautical mile buffer outside of a 12 nautical mile buffer from a country's baseline coast. And so the 12 nautical miles was your territory. Mm-hmm. And then beyond those, another 200 nautical miles, that ended up being your exclusive economic zone or your right to use marine resources. Now, you can think about places like the United States, where you can go hundreds of nautical miles and in some directions and not hit another country. Mm-hmm. But you can think about places like the Caribbean. You can think about places in the South China Sea, for example. The Mediterranean, where even in the UK, where countries' exclusive economic zones don't go all the way to 200 nautical miles because another country's interacts. And so these countries then have to determine their share. And so globally, there's fisheries within these EZs. There's fisheries outside of them on the high seas that aren't governed by kind of national sovereignty. And you have different layers of regulation, different marine protected areas where you're not allowed to fish that kind of overlay a network of fisheries regulation. And as you move from one kind of invisible boundary in the ocean to another, you have a different agency that might be responsible, or a different country might be responsible for enforcing these regulations. And as a result, you get something called illegal, unreported fishing and unregulated fishing, IUU fishing. And this is a big problem for fisheries. It's one of the drivers of overfishing in the world. And there's a really great program. There's a website called the Global Ocean Watch. And the Global Ocean Watch uses satellite data at night. So you can see night lights of where fish boats have their lights on at night to track where they're supposed to be or not supposed to be. And also these kind of reportings from transponders on boats that tell you where boats are in the ocean. And they're actually able to track where some of this illegal fishing is operating in the world, even though someone might not be out there to observe it.
Okay, I see. Yeah, I can imagine it just being a little bit contentious in places like the Mediterranean. I mean, quite frankly, even with the UK and Europe, I mean, part of the reason why some people voted for Brexit, not too long ago, was to have sort of more control over the waters in and around the UK. And there was even like a bit of a contentious issue in regards to the 5-year period where the European Union could still like use the UK fishing areas basically before, Brexit essentially set in. And I think a lot of people thought that, and I think that did happen to a degree, that a lot of the European countries just kind of raided the fishing larders basically for a period of time. I mean, which is just one example of how territorial disputes can sort of come in this direction, let alone places like the Mediterranean or the Middle East even potentially as well, where, political relationships aren't great at the best of times, let alone with things of this nature as well. So in this regard, then, what's the best thing we can do as global policymakers in our different countries to really help manage our fisheries in a sustainable way so we still have them for the future, but still are able to profit off them in the short term?
So I think that one of the things that we don't always have a good concept of is how valuable fish resources are.
Mm-hmm.
We know what they sell for at the market, but that might not be reflective of the true opportunity cost of leaving a fish in the ocean, because that fish, as we started at the beginning of our chat, will reproduce.
Mm-hmm.
And there are places where we're selling fish at the market for less than the value the value that we have for it had we left it in the ocean.
Right, because it's almost like an investment cost essentially.
Yeah, and so this is a big part of my research, is thinking about ocean resources as assets, thinking about natural capital, nature as a capital asset, and how can we bring an understanding from finance, from economics, to better manage our natural resources. Now, there's a lot of analogs between, for example, the Alaska case and this way of thinking. Instead of thinking about fishers operating on fisheries, you can think about portfolio managers with the different stocks that they hold assets in, that they hold stocks in. So the different equities that they hold stocks in. So you would have one fisher that's a portfolio manager that has a portfolio of different fisheries that he or she is allowed to operate in.
Sure.
So then we have to think about, okay, what is the asset value of the fish that this individual holds the rights to fish for? And that has to do with the reproduction of fish, projections about what that fish might sell for in the future, and how you value future fish relative to fish today.
So I guess the way that we'll sort of to round this out is, what research would you like to see done in the future to help sort of capitalize on this research? Or even what research would you like to see conducted, or you think would add a lot of value to society in regards to the fishing industry potentially, or quite frankly, just environmental economics in this kind of regard, generally more speaking?
Yeah, so the first thing I think to mention is that we've talked a lot about this market where fishers go out and fish for resources for fish. Now, if everyone is allowed to participate, we have this classic case of a common pool resource, or the tragedy of the commons. We try to regulate that market failure to internalize the externality and more sustainably manage the resource. We haven't talked about ecological change and how climate is adding an additional pressure with ocean warming,
right,
ocean acidification, and sea level rise. That's not just going to change the way that fish behave and their ability to reproduce in the future. It's also going to affect how people behave. And I think it's really important that research understands both how the ecological system changes, how the human system changes, and how those two things interact. So that's kind of where I think the exciting research is in the frontier. And there's a lot of it already happening. So we are smack dab in the middle of the UN decade for science for ocean sustainability, or sustainable development for the oceans. I probably messed that up, but you can find out what the technical term is. It's basically till 2030. The UN has decided that we should invest a lot of resources in the science behind sustainable development of the ocean and ocean economy. And so we're interested in figuring out, how can we treat natural resources like financial assets, or like produced capital assets that we already have good measures of at a country level. So GDP would measure our productivity of produced capital, but it might not capture things like the degradation of natural capital. So how can we bring all these things together to understand not just how fisheries operate and how we should best manage them, but how we should best manage them in the context of a changing world and a climate crisis?
No, I think that'd be very incredibly useful. And as you quite rightly say, as the climate is changing over time, as demographies, quite frankly, are changing over time, how urbanization rates are changing over time, these are all going to be things that are going to have different pulling factors on different resources, not just fisheries in general, but other resources like freshwater and things like that around the world, and understanding the dynamics that play in between the resource scarcity, the usage, and the sustainability replenishment aspect, I think is really, really important, not just for, like say, fisheries, but for things like freshwater, for things like agriculture, forested regions as well. I think would be very, very important as well, quite frankly, as well. So
one thing that people might not know is that when you mentioned forests, most of the other resources that you mentioned are far more valuable in monetary terms than the value of fisheries. Fisheries are surprisingly less valuable than a lot of industries and a lot of other natural resources.
Okay.
So I think it's always interesting to discuss why this is an important area to study, and why oceans are so important. I mean, we know that oceans are large. We know that it's the largest ecosystem in the world, but what we might not realize is that 40% of the world's population lives within 100 kilometers of the coast, and that includes nearly all of the UK. I think the furthest you can get from the ocean in the UK is 113 kilometers. So there are a lot of people who rely on the ocean, but there are also a lot of sensitive populations, small island states, that rely on the ocean as their primary source of protein. There are 1 billion people on the planet who rely on ocean sources for their primary source of protein. So it's not all about the money. The ocean is super, super, super important. And thinking about fisheries is while we can use economic tools, we shouldn't lose sight of kind of the bigger picture of how important the ocean is.
No, and that's the thing as well with a resource like that. It's things like forests, for example, perhaps it has more tangible use factors. It can be manufactured into furniture, it can be used as a fuel source. There's a variety of things like that. Whereas it's really just a primary resource fish for the most part. It's just going to fuel. It's a primary source. There's not a lot of manufacturing or anything that goes on outside of that to increase the value and things like that. So potentially the industry itself is a little bit less expensive, but I think obviously it has a lot. You brought this up earlier. What's the opportunity cost? If people aren't able to eat properly and they have levels of malnutrition, and then obviously we're not going to have those people doing other areas in industry that are able to work, develop, think, and do all these other things that we need for society as a whole. So like you said, there's a cost into not looking at these areas and really taking them into consideration, more so than the current actual monetary value, let's say, of the actual fishing industry and these fisheries. So no, I think that's completely fair, and I think we need to make sure we're doing a lot more research on that. Is there any research areas or anything you would like to reference to, or would like people to go have a look at whilst they're here?
Sure. I mean, we have there's a really exciting project that I'm working on now with colleagues from Oregon State, James Watson, and other institutions in the U.S. We're working on a $1.5 million grant from the U.S. Department of Defense Minerva Research Initiative, and that's called Future Fish Wars: Tracking Changes in Ocean Ecosystem Wealth. And so what we're trying to do is figure out how this climate pressure is reallocating fish resources across EEZs, and how those changes in the distribution of marine resources might lead to international conflict. And if we can understand what the changes in value are, the changes in the location of the fisheries are, their asset values, we could potentially use that information to help predict or resolve conflict on the high seas.
Superb. Great wider reading for everyone's go say listen to, but they listen to this, they're probably have to go read that. Thank you very much for watching, guys, for joining us on this episode. Thank you again to Ethan, and join us again for the next episode, and go check out Ethan's research if you are still around at this point. Thank you, Ethan.
Cool, yeah.
Thank you for watching this episode of the Marginal Babble podcast. If you've made it this far into the episode, please consider liking, subscribing and following, and also commenting down below any future topics you would like to see discussed. But until then, see you soon.